Hello everyone, I'm Milica Shuka and I'll be there as tech support during the tutorial. I want to introduce you to our tutor, Alexandra Ebert. She's a Chief Trust Officer and LinkedIn Learning Instructor at Mostly AI. She will hold the synthetic data advantage, how it helps you to get both AI privacy and the explainability tutorial. So everyone, enjoy.
Awesome. Thank you for the warm introduction, and also thank you for having me again this year. It was already a pleasure to talk and teach synthetic data last year at DSC, and so I'm happy that I was asked to come back. I think we are going to wait, I would say, like 1 minute or so before we kick off, but now I'm going to proceed with my screen sharing. Because one thing that we're going to need, you have this information also in the DSC platform, but also to have it here again. One thing that we're going to need for our tutorial on synthetic data is obviously some synthetic data. So if you could use the first minutes to create a free account on the Mostly AI platform, this will help us to speed through this part later on during the tutorial. Also, we are going to use DataCamp, or I'm going to use DataCamp for the notebook that we have prepared. You also have this link already, I think, on the DSC platform as well as in the chat. So if you don't have a DataCamp account, you can create a free account there as well. Or if you prefer, you can also just download the files from there and use Colab, use your own environment, whatever you want to do. Speaking of the chat, we also have my colleague Nick Jewell here, who is going to help me monitor the chat, or actually he's only monitoring the chat. I can't do that while I'm presenting, and is helping you out if you should have any issues, both from a technical side, but of course, Nick also has expertise in synthetic data. So if you have any questions regarding synthetic data, Nick also will be able to answer them, or he can help me collect the questions, because there will several points throughout this tutorial where I'm happy to answer your questions, of course, as well. Yes, so I will leave this here for a few more seconds, but as mentioned, the link is also in the chat. And with that said, I see that we also have quite some participants here as well. I would suggest we proceed. So what are we going to cover on synthetic data today? Well, first, we're going to cover what is AI-generated synthetic data actually, because believe it or not, there's quite some controversy around this topic and not a clear definition. Then we will, of course, create synthetic data ourselves, and not only any synthetic data, but one that's super realistic and representative. This type of synthetic data that's particularly interesting to data scientists and people that want to do machine learning, because it has the same quality and the same patterns and structure as your original data. And we're also going to look into how to assess synthetic data quality, because this is actually one of the most interesting questions to anybody starting out with this new technology. Can you really rely on synthetic data? Is it any good? Is it any useful? So we will look into ways how you can assess that. And lastly, we are going to also look into synthetic data and how it can contribute to explainable AI without infringing privacy. And for those of you who've read the agenda or who have read the abstract for this session, if we have time, we'll also going to look into smart imputation. But let's see how long it takes us to go through the things that I just mentioned, and of course, I'll answer all of your questions. Good. So some housekeeping to make sure that you get the most out of this tutorial. In terms of questions, you can definitely ask questions at any time in the chat. I will also pause and throughout the tutorial and ask either Nick to help me select some of the questions that we had in the chat so far, or of course, if you have the possibility, I'm not sure, DSC team, you can also unmute yourself and ask your questions directly to me. So whatever you prefer. Then in terms of tools and data that we're going to use, I already mentioned this at the beginning, we're going to use the Mostly AI platform to synthesize the data set that we're going to use. Plus, we are going to use DataCamp workspaces or any other way to open Jupyter notebooks that you prefer. And here again, I've put the links so that you can already get access to both of those platforms while I'm still presenting on the slides and before we jump into the notebooks. And again, I also mentioned this, but just so that everybody who also now just joined knows it, if you have any issues, if you have any questions, Nick is with us the full 1.5 hours that we have, so feel free to reach out to him in the chat anytime, and I'm confident that he can help you resolve your issues. Good. With that said, I would say we dive right in. And the first question that some of you might wonder, wait, what is synthetic data actually? And synthetic data is a technology that by now is used by 8 out of the 10 top US banks, predominantly for AI training, but also for many other aspects that contribute to data-driven innovation. It's also technology that, according to the Joint Research Center of the European Commission, is the key enabler for artificial intelligence, both in business as well as in policy applications. So this is a first teaser, but before we get into what synthetic data now actually is, I always like to talk about why synthetic data needed. And traditionally, what you would now hear is the exact answer to this question. But from the feedback we had last year from our tutorial, we found what the participants reported that it would actually be easier for them if they first synthesize some data. So we're first going to synthesize some data simply because we want to let the platform the time it needs to synthesize the data set so that we then, once we walk through the theory and the primer on synthetic data, can use this data set for the notebook that I have prepared. So before I'm going to reveal why synthetic data is needed, a little bit unusual in terms of flow, we're going to synthesize data. So, and for that, we're actually going to need the Mostly AI platform. I think because I currently have the slides on the smaller screen, I'm going to reshare my screen here so that it's easier for you. So, as mentioned, the links are already in the chat. So to get the data set, you either can grab it from the DSC platform or you can use it. Let me expand here again. So, or you can use the data set that's provided in the notebook. Sorry, the Zoom window disappeared on me. It can only be a matter of hours until I resolve this. Here we go. Good. Screen sharing again. So, for those of you that are already in the notebook, you can see that there are 3 folders. And first, we're going to tackle AI privacy or privacy-preserving machine learning with the data set that we have provided here. As you can see, this data set is already split in the holdout and in the training sample. Plus, for those of you who can't access the platform or who don't want to access the platform, you can simply proceed with this synthetic data set that's already preloaded into the notebook. But for those of you interested in synthesizing data yourself, you can download the file here. And if you go to our platform and if you successfully logged in and also pressed the confirmation email, then you should have an environment that looks something like that. And then it's quite easy. I hope also it's big enough. Nick, did we get any comments that somebody can't see? Should I zoom in or is it visible just fine?
So at the moment, Alexandra, everything is visible on the screen. If anyone has any support questions, just use the Q&A and let me know. Perfect.
Thank you so much. Good. So we need to get our file here. We just downloaded it. And then it's a super simple process. So the platform here is set by default to provide you with high quality and anonymous synthetic data, which means you only need to click a few buttons. First, proceed. Then we're going to upload the data. Here we have the option to change a few things, but as mentioned, per default, the platform provides you with high quality, highly accurate synthetic data that's privacy safe. So for our purpose, we're actually only going to press the Create Synthetic Data button here. And then it's just waiting, which will give us time to go back to the presentation and dive a little deeper into the theory of synthetic data. And if you're curious, you can also here see the logs and what's happening besides. But as mentioned, we just want to get started. So once we are back with our notebook, we have the synthetic data set ready to proceed. So with that, I'm going to stop screen sharing again and come back to the presentation. I hope everybody already managed to follow along. If not, Nick is still here to help you, as mentioned. Just grabbing the data from workspaces, uploading it to the platform, pressing 2 buttons, and you're all set. So, with our synthetic data set being created in the background, and sorry, I need to find my slides here again. Let's come back to the question that I posed earlier. Why is synthetic data actually needed? And if you look into most organizations that work with privacy-sensitive data, you see this happening. Most of them have significantly more data than they had a few years, a few decades ago, but they also have this increasing challenge to access the data that they have due to regulation, privacy regulation, AI regulation, risk assessments, and many other aspects. And this is a challenge for many organizations pressured to thrive with data innovation or via data innovation. And it's a challenge that's definitely not going away in the coming years, because I work a lot on the policy side in the European Union, in the UK, and also in the US. And if you look only at the picture that we see currently unfolding on the European Union level, then we have the GDPR that many of you potentially know. We have the AI Act, also something that's talked about a lot recently, but we've actually something that's called fondly by policy professionals, the tsunami of new European data and AI regulation, because there are so many new laws coming out which have the same caliber as the GDPR, the same impact as the GDPR, to regulate and govern many more aspects of data. So not going to get easier to access data. You still have to comply with these laws. You still need to find ways how you can protect privacy. And this is by far not only a picture that we see unfolding in the European Union, that's actually something that happens globally. So Gartner stated a few years back that by 2023, 65% of the world's population will have their personal data governed under modern privacy regulations. I must confess, I didn't count. I can't tell you if it's exactly 65%, but just if you look into all the countries that are currently working on new privacy laws, I think they did a pretty good estimate here. And if you talk about the challenges of accessing data while complying with these laws, while complying with GDPR, while protecting privacy, one question that you very, very often get is, well, why not just anonymize the data? Because for those of you who are familiar with GDPR actually explicitly exempts anonymous data. So once data is anonymous, all the rules of GDPR don't apply. You're free to use it. The problem is that most of the legacy anonymization approaches were developed decades ago, in a time where we still had small data and not the highly complex, highly dimensional data, the behavioral data that we have nowadays. And the challenge with these legacy anonymization technologies like masking or obfuscation is that you can either have useful data or you can have anonymous data, but you can't have both. And to illustrate this, I think everybody here in our audience can guess who the person on the left is. So we can be pretty confident that this is not sufficiently anonymized. And the same actually holds true for structured data, which will be the focus for our tutorial. It's just not as easy and straightforward for us as human beings, as visual creatures, to know when a structured data set is sufficiently anonymized. So what happens if we anonymize it stronger? Is this now anonymous? And usually, if I were able to see your faces, I would potentially ask you to raise your hands. Usually when I'm presenting this slide, a lot of people in the room think that this is already anonymous. But in fact, it's not. There are so many papers out there that have shown that regardless how much information you delete, if you use legacy anonymization and there are still bits and pieces of real data left intact, then it becomes easy to re-identify customers and it becomes easy to infringe the privacy. So for example, one study looked into credit card transaction data, which is quite rich behavioral data, and where arguably your customers have a lot. If you work in a banking context, you have a lot of this information, a lot of this data. And what they found is that if you delete everything that you have as with a credit card data set, except 3 credit card transactions per customer or per individual, but not even the entire information of the credit card transaction is what you keep, but you only keep the merchant and you only keep the date of the transaction. So let's say yesterday Starbucks, the week before Walmart, and 2 weeks ago Amazon or something like that. Only this level of information was sufficient to re-identify over 80% of customers in a data set. So you see, arguably most of the customers of a bank will have not only a handful of transactions, but dozens, if not hundreds of transactions per year. And with legacy anonymization, you can only keep a tiny bit of information and already run into this re-identification, into this privacy risk, and also in a non-compliance with GDPR. And this is something that we've seen over and over again in all the different industries, with all the different data sets, and also with plenty of organizations who believe that they had anonymous data, like Netflix, AOL, only to then find themselves in the negative press headlines that data was not as anonymous as they thought it was. And the consequence when we look into these limitations of legacy anonymization is that today we have so much more data, but with legacy anonymization, we have this hard ceiling, this growing gap for innovation, because we can only ever retain so little information before we run into this re-identification risk. And to solve this problem, to find out how you can still use data while protecting the privacy of your customers, of your employees, of your citizens, this is why synthetic data, AI-generated synthetic data for privacy protection was invented. So now, finally going to answer this question, what is the type of AI-generated synthetic data now that we are looking at? And even though we are focusing on structured synthetic data, I still like to explain it with images, because it's just easier for us to comprehend. So what we can see here, and by now this is of course not so fascinating as it was 6 years ago, are super realistic images. And I assume that most of you could have guessed these are not real images, not real human beings, but they're real images, not real human beings, but they're synthetic images and they were created back in the times from an NVIDIA research project where they trained their algorithm on plenty of examples of real human faces, up to the point where the algorithm understood how does a human face look like? What are the features of a human face? Okay, humans have 2 eyes, a nose that is somewhere positioned in the middle, these skin shades, these hairstyles, and so on and so forth. So basically the synthetic data algorithm, the deep learning algorithm, learned everything that was to learn about human faces. And then it could be used to create completely new synthetic faces that have never existed before, but nonetheless were super, super realistic. And this is the same approach, plus privacy mechanisms, that is used for the type of synthetic data that you just created on our platform. So the setup here is that you have an existing but privacy sensitive data set. Of course, we just used a publicly available data set that everybody can use, but in the real world, the platform is used by organizations like banks, insurances, retailers, that need to anonymize their existing customer data sets without sacrificing the utility, which would be the case if they would rely on legacy anonymization technologies. So they have the existing privacy-sensitive, let's say, banking data, and then they put it through our platform on-prem, in the cloud environment, wherever they want to use it, to get synthetic data on the other side of the process, which is completely representative, which has the same structure, the same correlations, the same patterns, just as the original data had it. But it doesn't have any privacy-sensitive information of their customers in there, because in contrast to legacy anonymization, synthetic data doesn't distort, tweak, shuffle around the existing data and just tries to work around with it so that it's hopefully protecting privacy, but it's just learning from the original data and then in a completely separate step creating new data from scratch. And to make it happen, you first need a highly capable synthetic data generator, but you also need to have a row of privacy mechanisms in place that make sure that only generalizable patterns about your population are learned, even though to a very, very granular level, but nothing that is privacy sensitive, that is information that belongs only to one single individual or a very, very small group of people. And this is what gives you this high quality data that is nearly indistinguishable and as useful as the real data, but at the same time, privacy safe. And what I just explained here is also visualized on this highly scientifically accurate graph. But basically, in contrast to legacy anonymization, with synthetic data, you can never retain 100% of utility. This simply wouldn't be possible from a privacy point of view. But you can get super, super, super close to the value of your original data and the usefulness of your original data. And this is actually what we are first going to look into in the tutorial, how we can check that the synthetic data is close to the real data and as useful as our real data. Of course, synthetic data is not a silver bullet solution. It also comes with a few limitations. So one thing that we always try to highlight with our customers is that only because it's synthetic, only because it's protecting the privacy of your customers, of your employees, it can still be sensitive information. So for example, some banks wouldn't want to share their synthetic data freely because they're afraid that a competitor could learn who their most profitable customer segment is. All this proprietary business information, the valuable and sensitive statistics are still present in the synthetic data. So this is something you should be aware of when working with the data, that only because the privacy is protected, there could be other reasons why a data set is sensitive and shouldn't be shared freely, even though GDPR would allow you to freely share synthetic data. Then it's also not an approach where you need to come back to the real world data. So synthetic data or synthetic data generation is a one-way street. Once it's synthetic, there's no way back to the original. So it's not suitable for a scenario where you just want to temporarily protect privacy of a set of customers and then come back to the synthesize it and then come back to the real world data. And it's also not suitable for small data use cases. So of course the question then comes, what is a small data use case? There are many data sets where you could potentially use a much smaller size, but what we advise our customers to do is to start thinking about using synthetic data when they have 5,000, 10,000 data subjects. It depends on the data set, but this is a good starting point where you can definitely use this technology to get high quality synthetic data. It is not suitable if you're, for example, in a medical domain. We also work a lot with healthcare organizations, and you have some study of, I don't know, the rarest diseases in the world where you only have 50 members participating in your study. This is definitely too small to be anonymized with synthetic data or any other anonymization technology, to my knowledge. Good. Before we go to our tutorial, 2 more topics that I want to cover. First, again, highlighting what are the benefits, why is synthetic data needed. And I think the first point here, hopefully, is clear by now, because it eliminates privacy risk. It allows you to protect the privacy of your customers and still use data or even unlock data for machine learning use cases or other data use cases. A second benefit that's super interesting for the enterprise organizations we work with is the speed. If we talk to data scientists in large enterprises, they tell us that if they request data access, it's something that takes, if they're lucky, just a few weeks, but much more often 3 months, 6 months, even 8 months if they want to externally share some data. And with synthetic data, they can reduce this data or this waiting time down to a few hours or a few business days. So it's a big game changer for them in terms of speed to data and how quickly they can start working. Then it's also the accuracy. If you think back to the legacy anonymization approaches I showed you earlier, what you're left with once you have applied legacy anonymization is basically a Swiss cheese of data with lots of holes and gaps in the data. With synthetic data, on the other hand, if your original data set had, let's say, I don't know, 500 columns, 200 columns, whatever, you will get a data set from the identical structure, and all fields will be filled out just as in your original data set. So you will not have any Swiss cheese situation going on with your data set, which of course translates in much more utility and also more accuracy in your data and in the downstream use cases that you want to use it for. A big point for most enterprises we work with is also the collaboration aspect. If you work in the privacy and policy field, you know that sharing data is something that is super, super cumbersome, not only within organizations, if they, for example, have different subsidiaries in different regions of the world, but particularly if they want to externally share data. For example, if a big bank wants to collaborate with a startup. With synthetic data, because it is anonymous, it can be freely shared, and therefore it can also facilitate collaboration between large organizations and small organizations, or, for example, also some of our banks and insurances use it to finally access cloud resources for machine learning, because oftentimes they have internal policies and are not allowed to do that. So there are many ways how synthetic data can facilitate collaboration because it is free to share and there's no privacy risk attached to it. Then automation and cost saving is another benefit, and then it can also help with certain aspects of machine learning, but this is something that we can dive to later if we have time. So the last thing that I want to talk about, I mentioned it throughout the presentation, but I oftentimes get asked, well, what is the top use case for synthetic data? I can imagine so many areas where it is useful. And the answer is yes, there are so many areas where synthetic data is useful because it's more of an enabling technology as a technology that's used for one specific use case. Nonetheless, if I think of our customers, as mentioned, the banking, insurance, healthcare, industry, telco, even public sector, most of them are interested actually to use synthetic data for machine learning because the data requirements in terms of quality simply are the highest here, and they can't or they don't get very far with legacy anonymized data. But it's also used for digital product development, for software testing, for, as I mentioned earlier, third-party or external data sharing and collaborations. It's used even in a context for open data, plus increasingly also for responsible AI aspects like explainability, AI fairness, and many other aspects that go into that, even though this whole responsible AI ecosystem is still quite nascent and it's just developing. But as mentioned, top use case currently AI training. Nonetheless, it's an enabling technology that is useful in many, many areas where you need high quality yet privacy safe data. Good. With that said, I think I'm going to stop for questions, and then we will dive into our notebook and get hands-on. So at this point in time, as mentioned, I couldn't monitor the chat, but are there any pressing questions that you want to get answers? Or are you excited to go into our notebook and save the questions for later?
Alexandra, we've had one question in the Q&A from Harris asking about how synthetic data compares to practices like SMOTE for fixing imbalanced data sets. We provided a couple of great mostly AI blog links for that so far.
Oh, awesome. So sounds like we are all set here, and I think then we can proceed with our tutorial. So as mentioned, I would now like to come back to our notebook. Bear with me while I'm changing the screen sharing situation here. I just want to make sure that you see enough, and therefore pulling this back on the big screen. So I hope you can see my screen again. And actually what's of interest for us at the moment is this tutorial here. So as mentioned, first folder, AI privacy section, and the notebook that you can find here on the bottom of this folder. So the one thing that we want to look in this notebook is how good is the synthetic data that we just created, because it's of course important to protect privacy, but at the same time we have utility requirements for our data. We want to have useful, truthful data, and therefore it's good to have ways how you can assess your data quality. And what you see here is an explanation how to use our platform, which we can skip because we already did this. But we definitely need our synthetic data sets. So let's keep our fingers crossed that everything worked fine. And you can go back to the platform. You can click on it. If you just want to download it, you don't even need to click on it. You have a download button in the overview. You have a download button here. But I just wanted to briefly show you that you can here also see a first QA report on the data. You get an accuracy statement. You can also, if you're curious, look into what this actually means, but it's much more of a first early indicator if the synthetic data process was correct, or if, for example, something was wrongly encoded. Let's say if you have zip codes and you encode them not as categorical but as numerical variables, you would quite quickly notice this in the overall accuracy, and also when you look at the different distributions of your data set. So this is the very first kind of way to assess synthetic data quality. Just a brief visual comparison. It's quite nicely matched here. So the gray line that you can't even see, let me see if we have a plot where we see it here. You can see a little bit of gray on the peak. This is the real data set. The green is the synthetic data set, and you can see that this matches quite nicely. But we are, of course, interested in understanding if our data is useful for machine learning. So we're going to download our data set as CSV. And what we need to do then is just unzip this file. I have this on my other screen here. And to make sure that our notebook works, we need to rename this to now not training, but by now it's a synthetic data set. So, and then we have our synthetic data set ready to test it in our notebook. If you didn't synthesize your data set, if your run didn't finish, you can just use this one and just rename the data set by deleting the backup and just renaming it to synthetic, oh, sorry, my data camp has a little bit of an issue, so I'm going to use this approach. So, wonderful. Now we have our data set in there. What we're going to do next is first importing our packages and uploading our data. And then we can also do a first exploratory data analysis by looking, for example, at 10 random samples of our data sets. And this is now the synthetic samples that you can see here. And as you can see, sorry, I didn't even tell you something about our data set. Beg me pardon. The data set that we're going to use here is actually a publicly available Airbnb data set. As you could have guessed from the name, it's from Paris. It has 56,000 records roughly, and we already split it into a 80-20 training versus holdout sample. And we have 17 columns in this data set, different types of information, plus one binary target variable, which is actually the cost of this Airbnb accommodation. So as you can see here, there are just two options. Either the accommodation costs below $100 per night, or it costs above $100 per night. So that's the data set we're looking here. And you can already, with the synthetic data set, see the granular structure of the data set. So you can, for example, see, okay, this person is a host since 2015. You can also see how quickly a host usually responds, within a day, within an hour, whether this person is a super host, in which neighborhood the Paris Airbnb accommodation is, what property type it is, so if it's an entire rental unit, if it's a room in a hotel, and so on and so forth, how many people it accommodates, how many bedrooms it has, and some other attributes. So that's basically our data sets. It's Airbnb listings, and we can also, Nick, I can see you in the tutorial. And we can also, for example, specify, okay, please show me some random sampled listings that have a rating below 4, but at least 10 ratings. So not just one outlier rating where somebody was angry at the host or something like that, but where people apparently weren't as satisfied as with other accommodations. So you can already see quite nice for exploratory data analysis. Of course, you could also just take this data set, pop it into Tableau and continue there. But we want to figure out if the data set is good for machine learning purposes and if it accurately reflects the patterns and the correlations that we had in our original training data set. And this is what we're going to do now. And the setup that we have here is something that's commonly referred to as TSTR, which stands for Train Synthetic Test Reel. And this is the process. So we have this actual holdout data set, which you can find here. This was never used by the synthetic data generator. It's not going to be used in the model training stages. It's just used for the evaluation of both models. And then we have our actual training data sample. This is the one that we just downloaded, and from which we created synthetic data. And then we are going to train the model on 2 different data sets. First, a model that's just trained on the actual training data, and then a model that's trained on the synthetic data. And we are curious to compare the performance via the holdout data set to figure out how good is our synthetic data set. Did it accurately reflect the patterns and correlations in the machine learning model, in the actual training data? And this is why machine learning is just such a good way to assess this, because it really deeply looks into the underlying patterns. And if we didn't have them in there, then the test would quickly show some flaws and performance issues with the synthetic data. So that's our setup. And to do that, we are going to train a light GBM classifier. And as you can see here already, everything is specified. So our target column is price, and our target variable is we want the model to predict if accommodation costs above $100 per night. So if it's a rather expensive accommodation or not. And if we look down, the first thing that we want to assess is actually how good is the model that's trained on synthetic data. And we're going to look at the accuracy, we're going to look at the area under the curve, and we also have a plot that we've specified above that can help us to figure this out. So let's train the model on our synthetic data. And since it's a very small model and a very small data set, we already have our result. And we can see the accuracy is 81.5%, and the area under the curve is 89.7%, which already looks like a quite promising result. And in this plot here, you can see the actual results. So if the model is, or if the probability is close to 0, then the model is very confident that this is a lower priced accommodation, so something that costs below $100 per night. If it's closer to 1 or very close to 1, then the model is very, very confident that this is a higher priced accommodation. So that's the distribution that you can, or basically you can here assess the distribution of the scores and better understand how the model performed. And with the color-coded elements in here, you can see what the actual results were. So here we can see that for most of the samples where the model was very confident that this is a low-priced accommodation, we see the blue ones are the low-priced ones, that it was actually correct. Only for a tiny bit of high-priced accommodation, the model predicted that this should be a low-priced accommodation, which was wrong. The same picture we can see here for most of the actually high-priced accommodations, the prediction of the model was correct. So it looks like quite good performance. And here in the middle, we see that this is, of course, closer to a 50-50 split. So looking quite good so far. But the most interesting point is, how does our machine learning model fare that's trained on the real data? Is this significantly better? Is it worse? Is it similar? So this is what we want to find out next. And therefore, again, we train the exact same model, but this time not on synthetic data, but on real data. And what we can see here is a picture that looks rather similar. I must confess, I didn't remember the numbers by heart, so I need to scroll up. But just from the visual point of view, we can see this looks quite close. So we had an accuracy of 81.9% on the real model versus 81.5% on the model trained on synthetic data. And the area under the curve here is 90.1%. Versus here we have 98.7%. So we can see it's super, super close. And also visually, this is quite on par. So this is the way how you assess, or how also most of our customers assess, the utility of synthetic data. And of course, some of you can now say, well, this was just a toy data set, but therefore I would actually encourage you to try this out with some more complex, higher dimensional data sets, because I'm pretty sure that you will get the exact same picture here, that synthetic data performs on par. And again, it's not only the on par performance or the performance that's super close to the real data, but it's this benefit of privacy protection. Because for most organizations, it's not even this question of, okay, am I slightly better if I were to train on the real data? They aren't allowed to use the real data. So it's either not having a high quality model trained on synthetic data, or using synthetic data and having something that's super close to what they would have gotten if they trained on the real data. And therefore, this is the first part on how to assess synthetic data from a quality and accuracy point of view. So here you can only see, if you're curious, the data preparation steps. We're not going to walk through them now, but we will continue with the explainable AI section. Before I do that, again, are there any pressing questions or anything that you would like to have answered?
All looking good from this side, Alexandra.
Perfect. Then let's continue with the explainability section. So with explainability, one big challenge that we oftentimes hear from customers is that privacy is an issue, because in most large organizations, it's on the one hand, of course, interesting for the developers of a model to assess whether a model is fair, why it came to decisions, and so on. But oftentimes they also have this internal governance step where another unit, another department, a model risk unit, AI governance unit, needs to assess the model for explainability, for fairness, and other characteristics. And this is something that's super hard to do, because you oftentimes need to have granular data to assess whether or how a model came to its decision. It's not sufficient to only share the code. And this is, of course, a privacy issue, particularly if you not only want to have this exercise internally, but want to have external AI audits, which is also something that larger organizations are looking into with all the AI regulation that we have on the rise, simply to secure themselves against different risks. So the second part of our tutorial is actually looking into how we can use synthetic data to facilitate explainable AI. And what we're going to do here is actually making use of Shapley values, which are a quite nice way how you can dive deeper into the inner workings of your model and get an explanation of why certain predictions or classification happens. but Shapley is something that requires you to have the code and the data. So without the data, you wouldn't get any explanation, and without with granular data, you have the privacy issue. And this is how synthetic data ties in here, because it can provide you with the granular data that accurately reflects your real data, but in a completely privacy-safe manner. So let's look into how this is going to unfold. We are first going to install our Shapley package, and we can also again import our data and all of our libraries. Pressing would definitely be helpful if we want to execute something. Good. So now that this is prepared, we're going to train the exact same model again on real data, not on synthetic data, because we want to have an explanation of the model trained on real data via the use of synthetic data. So we're only going to train the model here that's using real data and not the synthetic data set that we created earlier on. And then we want to calculate our SHAP values. This again will take a little bit because it's now calculating all the SHAP values on the synthetic data. And then we can look into a few plots that we prepared to better understand what the SHAP values are telling us. So the first thing, I think there's actually no need to reloading it because it's anyway not going to change. But the first thing that we're going to look at is the overall feature importance. So basically here, what we can see is which of the features that we have in our data set contribute the strongest to the prediction of a model. And here again, the number one predictor, the most influential variable or attribute here is how many people an Airbnb accommodates. And this makes sense because if an accommodation only accommodates one person, then it's kind of expected that this accommodation is cheaper than a accommodation that, I don't know, would be able to house 5 people, 6 people, 10 people, or however many people. We also can see that the neighborhoods contribute to the overall prediction of whether or classification of whether this accommodation now is a pricey one or a cheaper one. And this again makes sense. I didn't walk through this with you earlier, but we basically have different neighborhoods from Paris present in this data set, and some of the neighborhoods are more in the outskirts versus other neighborhoods are more in the central area of Paris, where you have all these beautiful sites and of course all the tourists want to stay at. So it is expected that those more central neighborhoods are significantly more expensive than if you would rent an Airbnb that's more in the outskirts of Paris. So this so far is not very surprising. What's maybe not very intuitive is why the minimum nights are the third most decisive element here, because I wouldn't be able to intuitively come up with an explanation of, okay, why should an accommodation that requires me to have a minimum night be more or less expensive than one where I need to at least stay 2 nights or 3 nights. Then we have the host response time, how many bedrooms, and many other elements, but we can already see from the plot here that they don't have as much impact as the ones that are right on top of this plot. So now we have a better understanding of why our model classifies an accommodation or predicts an accommodation as being more expensive versus not. What's interesting also is that with Shapley values, we can not only look at this overall feature importance, but we can also look at the values and the value dependent impact via the dependency plots. And as it's written here, there we can see on the one hand the average lift, but then also this level of variance of that lift. And this can sometimes reveal some interesting aspects. So for example, if we look at the dependency plot for the number of people that an Airbnb accommodation accommodates, we see a quite nicely distinct picture that, okay, the more people can sleep in that accommodation, if there are 8 people, it's quite likely that the model will predict that this is a higher priced accommodation, versus if only a few people can sleep in that accommodation, then the prediction or the result should be that this is a lower priced lower priced accommodation. Also, when we look at the neighborhood dependency plot, for example, here we again have this picture of what I just explained earlier, that the neighborhoods that are more interesting to the tourists, because we have all the nice and beautiful sites and areas of Paris in these districts, in these neighborhoods, they contribute to higher prediction or to a more certainty of the model that this is a higher priced accommodation, versus the more outscared areas of Paris detract from the value and therefore bring the result closer to, okay, I'm pretty confident that this is a lower priced accommodation. But again, the result here is not as strong as with the accommodations overall, so it's a similar picture, but the effect is not as strong. And I also prepared a few other ones, but the one that I think is most interesting here is the property type dependency plot. And I'm actually going to go back on the top to look into the overall importance of property type from a features perspective. So we see that the property type here is somewhere in the middle field. It's not a very strong indicator of if an accommodation should be high priced or not. But the question is why? Because if we just look at this dependency plot here, then we would assume that this should make a big difference to the result and what the model assesses. Because, for example, for the Airbnb accommodations that happen to be an expensive room in a boutique hotel, they are quite a strong indicator that the accommodation is higher priced. Similarly, if we have a shared room in a rental unit, so a room that you rent and have to share with some other folks that you don't know, this is a good indicator that the accommodation is rather cheap. But it's not reflected like that on the overall plot that we looked at earlier. And the reason for that is that all of these are more of the outlier cases that, if you look at the data set, appear quite seldomly, and therefore, even though individually they are good indicators, they don't have a strong impact on the overall picture that we looked at in the plot above. So this is a few of the things that you can look at with these dependency plots. And lastly, one thing that's super nice if you use synthetic data is that you can also look at the chat values for specific single samples or random single samples, which is something that simply wouldn't be possible if you were to use real data, because you can't just grab your customers or your customer database and just go through each customer one by one to analyze this. This would be a huge privacy infringement. So here again, we can show some random samples. And with these force plots, we get a graphical representation of what the prediction was. So for example, here I had these are both quite low. So here the model is quite confident that this is a lower priced, that this is a higher priced. No, I'm confused, sorry. We had the response time, we had the entire home apartment. Exactly. So here it can tell us why it believes that this is a higher priced, a lower priced unit, because the number of minimum nights are a big contributor. It's also only one bedroom. It's also in a neighborhood that's not that expensive. Sorry, this is a low priced accommodation. And we can also look at the extreme outliers, or for example, in that case, the absolute lowest score that we had. So this is even lower than the other one. So here the model is super certain that, that this is a low priced accommodation. And if we look into the different attributes here, we can see, okay, why is this probably the case? Well, only one person can sleep in this thing. It's a private room in a rental unit, so you have to share it with others. You have to have 30 minimum nights, which is quite a lot. And these are some of the factors that contribute to that. Similarly, you can also look at the highest score and see, okay, why is this suddenly something that's very, very likely to be expensive? And here we see it again, room in a boutique hotel. This is definitely not something that you're going to get get under $100 per night in a good neighborhood in Paris. And one other thing that we can do with synthetic data, even though this is again a more newer area, we can also use our human expertise to create more diverse samples that maybe weren't even present in our training samples, but to assess, okay, how would the model decide on individuals that are likely or that are possible to be encountered in the real world. And this is also something that some regulators and also audit companies are looking into. How can they create synthetic data sets that are not only diversely representing our population, but that are actually hyper diverse, where we have plenty of examples of extreme outliers, to make sure that we can really stress test models also in a fairness context, but also in this explainability context, and better understand how decisions come into existence. Good. So again, I'm stopping for some questions.
Yeah, nothing from our side. So please get them into the chat or into the Q&A window if you have any questions.
I'm going to wait a little bit because we were actually so fast that we don't have much left for our tutorial. So not sure if there's anything you're interested to learn about synthetic data, or if you are interested to share what brought you to this tutorial, why you're motivated to learn more about synthetic data. I think we will have some time left for additional content, so we can either close early, or if you share some other areas of synthetic data that you would like to learn more about, then we can maybe also add a little bit on these elements. Good. While I wait here for your questions, I will also prepare the smart imputation. Looks like we still don't have any question. So looking into the last thing that we prepared, then as you want, we can either answer additional questions if they may come up, or we can also conclude earlier. But the last thing that we prepared is actually a newer application area of synthetic data, namely how we can use it to smartly impute missing values, gaps in your data. We already had one question in this direction earlier, and we also have a blog post that my colleague shared, which compares synthetic smart imputation, which some of the other imputation approaches that you might be familiar with. But basically what you can do with our platform, if you download this, in this case, we have the adult census data set, quickly introducing the data set, even though I assume that everybody knows it, but it's basically a US census data set where we have different attributes from the US population, demographic attributes, plus it's oftentimes used to predict then if a person has a below $50,000 or above $50,000 income. So that's the traditional data set. What we did here was that we artificially removed elements of this data set. You also have the data preparation script and how we remove this at the bottom if you're curious, but basically we randomly removed values from the data set to impute them later on. In this context, we concentrated on age, if I'm correct, and therefore we are now going to look into how we can use the platform to smartly impute these values and then compare this with the actual ground truth data set that in this case is available. And the reason why it's sometimes interesting to use smart synthetic imputation instead of other approaches is particularly if you have some parts in your data set missing where you don't know what the underlying patterns of this missingness are. And if you don't just want to bluntly, I don't know, for all the professors, for example, that didn't provide any information, assume that they are plus 50 or something like that, between 40 and 60 years old, but have a few professors to learn from, then the synthetic data generator is usually quite capable to understand the underlying patterns of your data set and more correctly guess what to impute a missing field with, as opposed to just using some averages or random filler options. Good. Using our data set here, I'm sorry. I'm going to use this approach again. We are uploading the data set now. I'm not going to change anything here. We still want to have high accuracy and don't optimize for speed or turbo. This is anyway something that's not relevant for data sets with this small size, but our customers use data sets with hundreds of thousands or millions of customers, and they sometimes just want to have a fast sample or for a use case where accuracy isn't the highest priority. And if we look into the data settings, and scroll down to the last column, we sorted this data set so that age is the last column, because still you need for our platform currently to move the column that you want to impute at the very last slot. But this is something that we're currently working on. So in the future, you don't need to take care about this order, but currently that's the case. So we sorted it to make age the last column. And then the only thing that we need to do is actually activating the Smart Imputation, saving this, and creating the data set. And I already synthesized this earlier, so I'm not going to wait for this to finalize, or I'm actually going to use the one that we have in the tutorial, because for naming conventions. So we have our imputed data set already uploaded here. Therefore, again, if you don't follow along, if you don't use the platform currently, the notebook will nonetheless work. And I'll just run through the entire notebook here. But basically, what we see here is that we have some null values in our age. And here we see our overall age distribution with the missing values. And this is just something that we need to remember for the plot that I'm going to show in a bit. Here again, this is also something I'm zooming in here now, because otherwise I would need to scroll through the history of my platform. But what you can see here is that with the imputed data set, suddenly this doesn't match up. But you see that the synthetic data deviates from the distribution that it had in the training sample, because this is where it imputed the values into. And the question now is, did it make a good guess? Did it do this in a meaningful manner? And did it actually bring us closer to the ground truth? So again, we can here see what I just shared, but zooming in, we have the original data with our missing values, and we have the synthetic data that's imputed. And the question now again is, how does this compare to this ground truth, the original census data set where we randomly pulled out some age values? And this is what you can see here. And here you can see that the synthetic data actually came closer to the ground truth data, and therefore helped to get you a more accurate picture in your data set. And the benefit, of course, we know imputation can take time, is also that this is quite fast. Of course, again, a toy data set scenario where we randomly removed some of the samples, and therefore we are super curious if you test this out with some of the data sets you work with, to also hear your feedback on how this performs for you and if this is something that you find meaningful. Yes, so this is basically the last section that we have prepared, and quite unusually, we still have a lot of time left. So I'm again pausing here, asking for your questions. And if there are no questions, then we can either conclude earlier, or you shoot a topic in the chat that you're curious to learn more about.
We obviously have a very studious bunch today. I've asked a question about whether anyone working in various industries or organizations might have any questions about how synthetic data could be used in their companies. But we'd love to hear from you in the Q&A. We can be here as long as we need, or you can type into the chat directly.
Absolutely. And also, if you don't have any specific question, we are also always super curious for your feedback. Also, last year we made a quick feedback round. So if you are comfortable to share it in the chat, or even by unmuting yourself, then we would be super curious to hear if you enjoyed today's tutorial, if there was something that you would like to see in a future tutorial, something that you didn't like, something you would like to see improved. So also curious for that type of contribution and comment. looks like nobody has something to share. In that case, there's nothing left than to say thank you for your time, thank you for your attention, and I can definitely encourage you to play around with synthetic data. One last thing that we can share: if you want to continue your journey of synthetic data, we actually also have a public GitHub repo where you can find several more tutorials, for example, on synthetic text generation, geolocation data, multi-table setups, and so on. Oh, I actually need to find out where I can put something in the chat. I think here. Nope.
It's all right, Alexandra. I think I've got it in the chat.
You've got it in the chat. Awesome. Nick here to save the day. So there's the GitHub repo. For those of you curious, you can definitely check this out, play around with the data sets that are provided here, but much more fun, of course, to use the data sets that you're accustomed to work with every day. So if this is something you're interested in doing, there you can find the link. Perfect. Well then, thank you so much for your time. Enjoy the rest of DSC, which just kicked off. And also thank you for DSC for having us again.
Thank you, Alexandra, for this great tutorial. It was really interesting. And thank you for all the attendees. Thank you for listening. And yeah, we hope to see you soon. Goodbye.
Thank you.